For exercise 1, the goal was to write a program that takes stock and price as input and then implement multiple if statements. So if the stock price is greater than 100, it's considered a high price stock. And then if it's between 50 and 100, it's a medium price stock. And then if it's less than 50, it's a low price stock. So I use Y Finance to fetch data from Yahoo Finance, so real time accurate data for the stock. So I made a function that gets stock price that takes the input of a ticker symbol. That was the parameter, and then it returns a float value that is the current price of the given ticker symbol. So here's the code for that, and then here you get the create an object, and then it fetches the data, downloads it with stock.history, the period of 1 day, so it gets the most recent day's data, and then it returns the closing price for the most recent day. And then here is the main program. So we first get the input from the user with the ticker symbol that they want the data to pull from. And then we have a try catch block here that but first it calls the function to get the stock price, and then it goes to the if statement. First checks if it's greater than 100, and then if it is, it prints out the that it's a high price stock. And then it's an elif statement that checks the other condition, which is greater than or equal to 50. And then the last one, else, if it's none of these two, would just be a low price stock. And then here's us running the main program, and I'll just do a small demo. So first, let's just enter the ticker symbol up here. So let's just do Microsoft. All right. And then down here is our output, which is Microsoft stock is a high price stock at 408.98. Create a program that calculates interest over multiple years using a loop. So first, I created a compounding interest for a function that takes in the parameters principal, the initial amount before the accrued interest, R, which is the interest rate, and then N, an integer, number of times interest is compounded per year, and then T, time in years. And then it returns a tuple with the total amount after interest and then the interest accrued. So we want both values. So how we implemented it here is first we created a copy of principal one because we're going to be updating it constantly in this for loop. So we had it here just so we can have part of the tuple, which is so we use it so we can calculate the interest accrued. So first we go a for loop which is 4 in range of n times 2 because this is the number of times number of times is compounded per year times the number of years. So let's say we do it quarterly, 4 times 2 years would be 8. So this is how many times we're gonna iterate over. So then we use this formula right here for compound interest. The principal is updated each time with 1 plus and then r divided by 9. And then that goes, and then we finally get our total amount. And then then we create a new variable that is total amount equals the principal. And then to create the interest amount accrued over the period of time, we do the total amount minus the initial principal, which we created a copy here. And then we get our return values, and then now we just gonna implement it in our main program. So first we get the user input, we get the principal, the rate, the number, the n, and the t. And we do it in their perspective data types, and then we call the function with the parameters inside, and then we format our output, and then we print out our results, and then we're gonna run the main program. Let's just do a little demo. Enter the initial amount, let's just do 1,500, and then the interest rate, let's do 5%, and then the number of times compounded per year, let's do quarterly, and then the number of years, let's do 5. And then now we're here on to the third exercise. We needed to create a program that analyzes the list of stock prices, finds the highest and lowest prices, calculates the average price, and then also counts how many days the price was above average. So like I used with my other functions, I used Yahoo Finance API to pull the data. So what I did, first I created this function that's stock price summary that's going to do all analysis. So first, we've taken our parameters of the ticker symbol as a string, and then it returns a tuple that has the average stock price, highest stock price, lowest, and count of days the price was above average. So first, we use Yahoo Finance to download the company's stock for 1 month, a period of 1 month, in intervals of 1 day, so we get the closing price for each day for a month, 20 days in total. So here we first check if the stock is empty. we return none. But here we use the built-in functions of Yahoo Finance that are applied to a data frame, which first we just select the column of close. That's the closing price for each day. So we select it first, and then we get the mean, and then we do dot item to get the scalar value. So here we get the mean, the average. Here we get the min, max, and then when we do counts above average, the number of days above average, we do a conditional. So we do stock price, and we select the close column, and then we just do a conditional that's above the average price, which we calculated already. Dot sum, dot item, and then we get our result right here. It counts how many days the stock price was above average. Then we got a return statement, and now let's apply it to our main program. So we first get the input from the user, the stock ticker, and then we call the function, and we assign each variable that we want, and then we call the function, and we're using the ticker symbol that the user gave us, and then we check if the average price is none, okay, to handle cases where data is unavailable. And then we just format our output. We use with the dollar sign for currency, and then we format it, and then we format each of the prices, the average, min, and max, not the number of days, because that's just an integer. And then we print our results in a formatted string. And then we're gonna run the main program just to have a simple demo. So let's do Apple, and then now down here we get stock price for summary for Apple, highest price, lowest price, average price, and days above average. All right, now moving on to exercise 4, create a simple trading simulator that loops through daily prices, uses if statements to make and buy sell decisions, and then tracks portfolio value. So I use both of these libraries, Y Finance and Matplotlib, for data visualization to track our portfolio performance. So first we created a function for trader simulation, and then it takes in the parameter of a ticker symbol. So first we get the ticker, and then we pull the data using Yahoo Finance like we've done before. We do it for 1 month, and we do an interval of 1 day. So we get the closing price for a whole month, and then we explicitly select the first and only column from the close data frame. So we just select the closing prices, and then we continue with the rest of our simulation. We're gonna simulate that we have $10,000 in cash, 0 shares, and then we're gonna create an empty list that's gonna store our portfolio history. And then so first we do a for loop from 1, and the length does how many days we have, then length of prices, how many days we have of closing prices available. And then we compare it, we do yesterday's price, and then equals price I minus I. So we're gonna look at the price in iterations, and we're just going to compare it to the one before it. And then here's our if statements. If today's price is less than yesterday's price, then that's when we go into a nested if statement that if cash is greater than or equal to today's price, we're going to buy more shares. And then cash, and then that's when we're going to, we'll buy a share, and then we spend that money, so we're going to subtract the cash from the today's price, how much of the share we bought. And then if that's not the case, if today's price is not less than yesterday's price, we do an elif statement that says if today's price is greater than yesterday's price. And then if shares are greater than nested if statement, if shares are greater than 0, then we sell a share, and then we pocket that cash here. So we're basically buying low, selling high. This is what the for loop and the if statements are meaning to do. And then finally, for the portfolio value, we do our final calculations. Cash times the number cash we have left over, and then shares times the today's price. Okay, and this is going to be for each day, so we're tracking our portfolio performance for each day. So this is all under one for loop. And then if we finally just we use portfolio history, we're just appending our portfolio history to this empty list we created in the beginning. And then finally, we do the final portfolio value, which is cash plus shares times the prices we have. And we return the portfolio history and the final portfolio value. And then this function is used to plot the portfolio history. So it's called portfolio history plot. So first unzip the portfolio history list into 2 lists, one for dates and one for portfolio values. This is what this code does. And then we plot using Matplotlib, using their annotation. the size, what we want plotted, dates, values, the markers, how we want them to look, the line, and the color, blue, and then plot title, portfolio value over time, date, yeah, the labels, X labels, the grids, everything, just the aesthetics of it. And then now our main function, we implement both. We get the input from the user, and then we, use a trading simulator for a formula. We call that, and then at the end we call we print out the final portfolio value, and then in the portfolio history we plot it using that function we mentioned earlier. So here I'm just not gonna demo it. I'm just gonna keep doing it. Just you input a stock ticker, and then it gives you, just example, for one day you bought one share at 236, and then it gives you the value of your portfolio. And then you keep going, and it just goes over and over and over again. And then here we can visualize it. So we start off with the 10,000, and then this is tracks it. We went down, and then it goes up, and the final was around, it's 1,015. It's $10,000 with $15. All right, and then exercise 4. We write a program that calculates total return on investment with monthly contributions over a period of years. So I created a function called investments return. So that calculates the total number of investments with monthly contributions over a period of years. So first we just print out a little title, investment return calculator, and then we get user inputs, and then we get the input from the user. We get the principal, the monthly contribution, annual interest rate, and years. And then we have the constants, which are the months, total value equals the principal, and then monthly interest rate, which is you divided by 12, and then we loop through each month. So in the range of months that we got earlier, that we put here. So we just reiterate over, and then we add monthly contribution. So that's what this line of code is, and then we apply the interest, and then we print out at the end final investment value after years, and then total value. So we're just gonna run it, and then the total investment amount, let's just say 10,000, and then monthly contribution, let's just say 500, and then annual interest, let's just say 2%, and then the number of years, 5, and then right here, final investment value after 5 years, 40,000, 25, or 26. And then we're looking at exercise 6, create a loan payment calculator that shows the remaining balance after each payment using a loop. So first we calculate the monthly loan pay. We use the function that's called loan payment calculator that calculates monthly loan payment and displays the remaining balance after each payment. So first we do a little title again, loan payment calculator. We get the user input, the loan amount, annual interest rate, and the loan term years. And then we get our constant monthly interest rate, annual interest rate divided by 12, and then our total payments, loan term years times 12. And then we use an if-else statement to calculate fixed monthly payment. So if the monthly interest rate is greater than 0, we apply this formula right here, which I can let you just see. It's just monthly payment formula. And then else we do, so if it's less than 0, we do a monthly payment equals loan amount divided by total payments, and then our remaining balance equals the loan amount. And then we print out monthly payment, and then that's where we print it out. And then what we do here, we loop through each month to show the remaining balance. So for a month in range of 1, total payments plus 1. Then we calculate the interest, principal paid, and remaining balance. And then we print out the month, remaining balance, and the remaining balance. Whether we're doing it for each month. And then this final if statement is just to ensure balance does not go negative due to rounding. So yeah, so if remaining balance is less than 100, it's 0. So and then we print out the loan paid over loan term years, and then monthly, and then we're gonna do monthly payment times total payments. All right. And then we're just gonna, let's see, loan amount, let's just say 100,000. All right, and let's just say 5%. Long term, let's just say 10. Okay, and then we print it out month, and it prints out all the way down to month 120, which is 10 years. And then for our final is $0. So that concludes for the coding portion, and then just a quick summary of my ChatGPT history. Is I just mostly looking at how to implement pandas with y-finance in Matplotlib, as well as giving me practice problems. And then I also asked it to give me good APIs for the project for this